Hello everyone, welcome back. So in this session we are going to discuss about the experimental features of Docker. So I think most of you are already familiar with what is Docker and how it actually helps in containerizing your applications. If you're using microservice-based architecture, then Docker is like a must-have for most of the projects. It is also a very important component when using, CI/CD like Jenkins or some other tools where you can actually build part of your applications as part of a Docker image and then you can push it to the registry. So yeah, I'm not going into the details of, the features and the advantage of using Docker, but let's discuss about the experimental stuff. So, what is this experimental feature? So, we can also know that out of the box, whatever Docker provides. So, here when I'm talking about Docker, basically Docker consists of two parts. So, it's like a Docker server, which is acting like a recipient of whatever command you are typing from your console or maybe from other application and the CLI or how you actually invoking the commands. So it's basically based on a client server architecture. So whenever you are using the experimental feature of Docker, you are actually using the experimental feature of both Docker client as well as Docker server, which is also known as Docker engine. So, what is the advantage of using, this kind of experimental features? So, as you know, that experimental means it's not there as part of the mainline product, right? So, there are teams who are working inside Docker who actually provide some cutting edge features just to compete with the market, which may not be. So, if you are using Ubuntu system or if you're using any Linux system like Arch Linux or anything, right? You may have heard about different channels, right? So the first channel is the most stable channel where you have a fixed set of applications which are already tested and that has a lot of process. And there are some bleeding edge features which are just came out. I mean, they are just released out of the developer workshop, and then people just starts testing them and they can use them, but at their own risk. So similarly, Docker also provides this kind of experimental feature. So now you might be asking that, okay, if I have these kind of features, why should I invest time to, learn about these things? Well, some of these features are already, tested and well established. So it's quite possible that these features will be part of the mainline product in the future version. So it's always good to know how you can, use these features to benefit your application in some distant future, right? So although the documentation says that you cannot use, or I mean, you are not encouraged to use these features in the production, but you can definitely learn about these features, and that's why we are here to explore these things today. So, um, uh, uh, and apart from this, features, so as I mentioned that there are two types of experimental feature, the client feature and the server related feature, right? So these features actually, if you see the trend, there are few applications and few features that came over last few versions of Docker Engine, and they are not even listed as the current set of experimental features, right? So whenever we are talking about these things, we are going to discuss about this version of Docker Engine, which is going to be 19.03. So as you can see, I have depicted some of the important experimental features. So as you can see, it has checkpoint features, it has squashed image features, third-party graph drivers, IPVLAN, and manifestation, and the build stack. So we'll have a brief overview of each of this. I'll start with the image squashing. Before you start with the experimental feature, you need to enable the experimental feature. So as I mentioned that there are two sides here. One is the Docker engine and one is the Docker client. So ideally you should enable the experimental features for both of them. So if you see the Docker engine and the Docker client, they have different configuration file. So whenever so by the way, I'm using this Docker version, as you can see, I have placed it. So it's 19.03 is the Docker server version, and the client version is 19.03.08 also. Okay, so let's try to enable the features. So for the server one, as you know, that's running as a daemon in Unix. So for that, there's a configuration file which is located inside etc docker. So here, as you can see, this daemon.json actually contains the configuration related information. Okay, so if you want to, I have already enabled it. That's why I'm just going to show you. You just need to place this simple tag experimental is equal to true, and that's it. And after that, you need to restart the Docker service. You can run using sudo systemctl restart Docker or whatever. So since I have already enabled it, I'm not going to execute it, right? So this way you can enable the server related experimental features. Now to enable the client related experimental feature, the user who is executing the command, right? So for that user, he or she has a home directory, and inside that home directory there is a Docker folder, .docker, a hidden folder. So for me, the current user is Lenaro, right? So I'm going to go into the home directory, and then inside that I have this Docker, right? If you see, I have this config.json. So this config.json is to enable the client related experimental features, right? So as you can see, I have other informations also. I'm not going into the details of that, but here just to enable this feature, you have to write experimental is enabled, right? And then you can restart Docker daemon. That's it. Okay. Although you are not technically required to restart Docker daemon because you are just enabling the client feature. So just by editing and then running Docker command should be fine, right? So let's start with the first experimental feature, which is image squashing. So for that part, I'm going to use a sample image. Let me go into the directory. So here on the top screen, if you see, sorry, in the top screen, if you see, I have a Docker file and I have a simple shell script. Okay, so let's go and see what this Docker file actually contains. So here I am just extending from the Ubuntu base image, and I have written very simple commands, right? I'm creating a directory, and then I'm copying the run.sh and then making it executable and then running it as part of the Docker image, right? So by default, if you create an image from this, like so if you build this image like docker build minus t, let's see what happens. Okay, so if I run docker build minus t demo, say name it as without squash. Okay, okay. So if I do this, right, it is going to create an image, right? Now on the bottom section, if you see, I have just written the same command here. But here the difference is I have added a special tag called squash, right? So what is squash? So if you know that in Docker, whatever image that you create is actually a collection of multiple layers, right? So only the topmost layer remains, editable when you are creating a container, but all the other layers are basically read-only, right? It's based on a container file system, like union file system, they call it, right? So that's the funda of how the Docker image actually there, right? But if you want to see the image layers, right, you can use the Docker history command. So once this image is going to be built, right, I'm going to issue the history command to showcase the layers, right? So if you see here, Docker image, let's wait for the image. Okay, so the image is ready now, and let's just see what are the layers of this image, right? So if you see Docker history and then write this image, which is demo without squash, right? You will see the layers, right? So this, the last few layers, right, as you can see, are basically part of the root image, right? Which is the Ubuntu image. And then whatever command that I have added for each Docker for each line in the Docker file, it has created a layer, right? And each layer has its own ID and the description, right? What is going to do, right? But if you see the root image, The root image is basically the Ubuntu image here. There also you can see various layers, right? But you are not able to, you cannot see this kind of image ID. So what is happening here is this, the root image is actually squashed. That means whatever layers it has, right? It actually being squeezed into a single layer. That's the funda of Squash, right? So in Unix, there's a type of file system which is known as SquashFS. If you do not know, so SquashFS is basically a read-only file system. Generally, it's read-only. You can make it, writable. But the advantage of using SquashFS is you can, expect a very, small and compressed image. So you can use SquashFS file system to share your ISO files or any package you want to, you want the client to use it as a read-only, reference. So so here, if you see, whenever I'm using this Docker image, which is the Ubuntu image here, so whenever I'm using this Ubuntu image, I'm not modifying the root image. I'm just using the Ubuntu image to extend my Docker image, right? So whenever the people who have developed this image, they know that you are not going to modify this image, you are going to extend this image. That's why they have actually combined all these layers into a single layer, and that's the final layer, which is this one. But for us, we have not added anything, so by default, it is going to create the image with all the layers. Now let's see if I build the same image with the squashed section enabled. Then also you will see all these images, I mean all these layers are there, but you will not see this particular layers that is added. So what is going to happen is going to squeeze all the layers into a single layer, and then it is going to add a comment that it has merged all the layers. So let's see, execute the docker history command. So if I use the docker history and the image name is demo squashed. So here you will see, similar to your Ubuntu images, I mean the layers of Ubuntu image, here our image layers are also squeezed, right? And the final layer that has been created, so there Docker has added this additional command that it has merged all these layers. Like as you can see, these previous layers into a single layer. So merging this to this, right? So what is the advantage of using this kind of thing? So to be honest, there is not much advantage. If you just want to make sure that this entire image is, dispatched as a single layer, then only it can be used. See, whenever you are downloading a Docker image from public Docker registry or a, private Docker registry, Docker can actually use parallel download feature, right? So if you have ever downloaded a long, I mean, an image with multiple layers, you will see that for every layer it starts to download preemptively, right? But whenever you do a image squash, what happens is everything comes to a single image layer. So Docker is not able to use this parallel download feature because it has only single layer. It has to wait for that. So if your network connection is not good, you may take a longer time, right? You cannot use this feature. But if you want to deliver or share this image as a final product to the end customer, I think squashing is always going to be useful. Now, keep in mind that it is not going to save the size. It is not going to reduce the image size. So people generally think that will squashing of the image also reduce the final image size. In most of the cases, it is not going to reduce, right? It all depends on how you're going to write the image. So for that part, you need to use the advanced techniques of writing images. So you have to minimize the number of layers and take necessary precautions. So that's a different chapter. But also there are some blogs where they say that if you are using Docker, environment command, say if you want to use a particular environment variable, then sometimes this image squashing might fail, right? But if you want to deliver your image as a final product, then I think squash actually makes a very good alternative, right? So let's move on and let's see the next feature. So for the next feature, what we are going to do is we are going to use this This is the third party graph driver that we are going to use. So what is this graph driver? So for example, here I'm going to show you an example like so on the bottom screen where the cursor is blinking, this is my Ubuntu desktop, and on the top I have this IoT board. Now, say for example, I want to share this particular directory, which is in the remote machine, to the container which I'm going to create inside my host machine as a Docker volume, right? So if you create a Docker volume, right? So I'm going to show you what Docker volumes I have, right? Generally, whenever I create a Docker volume, Docker actually allows me to specify the driver. But in most of the cases, it is basically a local driver. That means the file or I mean, the folder which is going to be mounted as a volume is residing on my local file system, right? I'm not using a remote directory to mount as a Docker volume. Although there are options to do that. For example, if you are using a Samba file share or a network mount, right, then you can put that mount into a volume, right? But Docker has no feature here, right? Docker is not able to identify whether it is being a local file system or a remote file system, right? But here, if you are using a third-party logging driver, right, then you can use it, right? So, for example, there are other features also. So if you use you created a Docker container and you want to view the logs out of this, right? So this log driver concept is whenever you are creating a container, you by default has the Docker default logging system, which is basically the JSON system, right? But if you want to use a custom logging system, then you can use it, right? So for this part, we are going to use the volume. So say this machine, right? So let find out the IP address of this machine, and so this is the IP address, right? So I want to mount this particular directory as a volume to a new container in my host, right? So for that part, what I'm going to use the Docker plugin command. So let's see what are the plugins available. So this third-party login, driver that you can see, that is also a plugin that I have already used. This is also part of the experimental feature. The other plugin that you can see is basically an SSHFS file system plugin. So SSHFS is basically a file system which is basically a remote file system. This is similar to Samba, but this has some advantage as well as some disadvantage also. So using this SSH file system, you can actually mount a remote directory from a remote machine as a Docker volume, right? So to download and enable this plugin, you need to, download this. So for that part, you need to run this command Docker plugin install and then name of the plugin. Since I have already done this, I'm not going to execute it. And after that, you are going to create the plugin like this one. So I have already created the plugin. Let me show you. So to create this particular SSHFS volume, right, I need to execute this particular command as you can see. So I'm creating the Docker volume, specifying the driver as SSHFS, right? Then I have to use the username of the remote machine, the IP address, the folder that I want to mount as a Docker volume. So it can be anything. It can be a root file system also, provided you use the corresponding user. So this user that who is getting part of the SSH command, right? That user must have write permission if you want to make this volume writable. Otherwise, it will not allow you to write any content, right? And then the password. This is just a sample password that I have provided. The port in which this SSH is working. If it is using a custom port, then you have to specify that. And then finally, the name of the volume. So once you execute this command, you are going to have a particular Docker volume like this. Okay. So let's see if I can create a container, right? So let's create a container. So Docker run -d, and then I want it to be ephemeral. That's why I have specified the -rm. Say the name is nc, and let's use a Ubuntu container and mount this particular volume, which is having this name to this location. Say it can be anything like say MNT test. So inside the container, it is going to be mounted as MNT test. Okay, and let's run the container using a kind of sleep statement. So this is still minus f dev null, which acts similar to sleep, and so it's going to create the container, right? So once the container is created, let's go ahead inside the container. Okay, and navigate to this particular directory, mnt test, right? So if you see, there's no file here, right? Because right now on the other machine, as you can see, I have just moved to the top machine. There's no file, right? So let's create a dummy file. So hello.txt. This is a sample text. Okay. So I've created this file, as you can see, right? Now it should be here now, as you can see. This is here, right? So this way I can share the content of a remote file system using SSHFS plugin. This is basically an advanced feature which you can see here using the Docker plugin command. Okay. Now, if you want this plugin to be disabled, you can simply disable this plugin, Docker plugin disable. You can also see what are the options that you have here, right? You have lots of option to disable the plugin, enable the plugin, inspect, whatever, right? One thing to keep in mind that, by the way, whatever volume you're going to create, right, the password is going to be stored as plain text. So this can, have some security breach also. So for that part, you should be, using a tool called RNG or random number generator to encrypt the content. So let's move on to the other part, which is a Docker manifest feature. So for that part, let me navigate to the other screen. So here now I'm going to discuss about this experimental feature called manifest. Okay. So what is a manifest? So whenever we create an image and we push it to the registry, be it public Docker registry or private registry, it has some specific information along with the image, right? So generally, the machine where I have created the image, the architecture of that Docker image falls to the same category. So for now, I am using an AMD 64 CPU architecture. So the image that I'm going to push to my private registry or public Docker registry will be having the same CPU architecture like AMD 64. But if you see, whenever you download a Docker image, that Docker image can be executed in a whole different set of machines, right? So in today's IoT world, you have edge machines like which are running mostly ARM architecture, right? ARM CPUs like ARM32, ARM Heartfloat, or ARM64, right? You can also have AMD machines. You can also have Spark CPU machines, right? So since Docker is not a complete virtualization, right? It runs on the host CPU and the host kernel. That's why this CPU architecture is very important, right? So this manifest is actually going to help you to identify whether a particular image that you're going to download from the public Docker registry is having the compatible architecture or not, right? So most of the time, say for example, I am running this command in a laptop machine which is running an AMD 64 architecture, right? So most of the, I can say almost 100% of the public Docker registry images are supporting the AMD 64, but that may not be the case for an ARM CPU. So before you download the same image to an ARM CPU, you can simply check whether that image is present for that particular architecture or not. And that is through using this Docker manifest inspect command. And this is the repository of the public Docker registry. So if I want to use my private registry, I'll write localhost colon 5000 / Ubuntu or something like that, right? So the good thing is you can create your own manifest, and then you can push it to the registry also, right? So for example, before we go to that, right, let's examine what are the features that I have. So for every layer of this particular Ubuntu image with this particular architecture, AMD 64, it is going to show you the type of the image, right? So for example, this Ubuntu image contains this many number of image layers. It is going to provide the digest information, and is going to include the size and the media type, right? So you can also download a particular Docker image. So for example, I want to download a Docker image for Ubuntu for this particular ARM architecture. Now, if I just down issue the Docker pull command, it is going to download the AMD 64. So for that part, I can use the digest number, this big number, right? So basically, not a number, alpha decimal uh, value. I can use this value to download. So that is the advantage, right? So if you see here, there are other informations also. So Docker manifest, and then if I issue help, you can see what are the commands that you can have. So you can create your own manifest, and then you can annotate it with information like what is the host architecture and what is the host CPU. These are mainly required whenever you are publishing your own image to a private registry, right? So, so we have, we have discussed about squashed image, we have discussed about graph drivers, we have discussed about manifest. Now, the final thing that I want to discuss is the checkpoint feature. So, if you guys have seen my previous video of Linux containers, there I was talking about a feature called versioning of the containers, right? So, whenever I am running a container, I can actually do periodic versioning. Either I can automate this, or I can write a command on, on ad hoc basis and then do versioning. Then it is going to create the image, I'm sorry, it is going to create the version of the container. That means whatever data is resided inside that container is going to be stored as a tag, and as a read-only tag, and then after some time you can also restore that container from that tag. So similarly, Docker has this kind of feature, but that is still as an experimental one. This is not present in the mainline Docker product. So to have this, you need to simply enable the uh, um, Docker server checkpoint feature, right? Whenever you are enabling the experimental feature for the server, you can simply find it. But the problem is this feature generally has a lot of dependencies. So I have seen it has dependency of a tool called CRIU, right? So this CRIU library is not very, to be honest, it's not that easy. And in many systems, even in traditional Ubuntu system or Arch Linux, you will find this to be very difficult, right? It has some dependency. So I'm not sure whether this feature is going to be, acceptable in the long run, because this has a lot of dependency. And none of these features that I have talked today, like squashing of the images, third-party driver, manifest, none of these feature actually work in Windows system. So if you are using Docker in Windows, you will not be able to, take any advantage from this feature, right? Final experimental feature that I have not discussed is BuildX. So this is about cross compilation of your Docker image. So since Docker is heavily based on the CPU architecture, if you are running an IoT project, it might happen that you have to create an image from a cloud machine where your Jenkins is running, right? But that image is going to be executed on a ARM CPU based machine, say a Raspberry Pi or a Dell Gateway 5000 or something like that, right? Which is running a different CPU architecture. So how you can actually do cross compilation? So that is something Docker has provided as an experimental feature called BuildX. It is using the QEMU virtualization in the background to achieve this task. But for this part, I am going to create a separate video later. So this is all about the experimental feature today. I hope you guys have understood some of the features. So yeah, if you have any comments, just suggest me in the comment section down below, and then see you in the next session. Okay. Thank you very much.